This is an example based on an example presented in the PBS Computer Science series called Crash Course. If you're not familiar with it, I highly recommend taking some time and viewing the lessons. Carrie Ann, the instructor, explains difficult topics really well. In this example, we're going to see how the primary components of the computer work together in what's called the fetch, decode, execute cycle. We're not going to discuss every detail of what takes place, but it will give you an idea of how the CPU executes instructions. Again, if you'd like to see the example in more detail, you should really watch the Crash Course series. So this is the view inside our CPU. In addition to the main memory we've talked about, the CPU has its own small area of memory called a cache, which is very fast, as well as even smaller locations called registers, which each hold a single piece of information. Periodically, a block of instructions is transferred from main memory to the CPU's cache to allow for the fastest possible processing of information. The memory you see here is the CPU's cache, with just 16 locations with addresses from 0 to 15. Our CPU also has 4 primary registers, 0 through 3. Our control unit also has 2 registers, the instruction address register that keeps track of the address of the current instruction, and an instruction register which holds the current instruction being processed. The first half of an instruction is the operation code, or opcode, and the second half is the address of a location in memory. For this example, our CPU has just 4 operation codes as shown in this table. Load 0 reads an instruction from the memory location provided into register 0. Load 1 reads an instruction from the memory location provided into register 1. Store 0 writes the value in register 0 into the memory location provided. And add adds the 2 registers provided and stores the result in the second register. Our CPU also has an arithmetic logic unit that performs our calculations. When we first boot up our computer, all of our registers are initialized to 0, and we've initialized our memory with a simple computer program. We begin the fetch, decode, execute cycle by fetching our first instruction. The current address in our instruction address register is 0, so the control unit configures memory to return the value in address location 0 and loads it into the instruction register. The control unit then decodes the instruction. Remember, the first 4 digits represent an operation code. In this case, 0010 is the code for load 0. Read an instruction from the memory location provided and place it in register 0. The second set of 4 digits is the location holding the value to be loaded in register 0, location 1110 or 14 in decimal. Now that the instruction has been decoded, it can be executed. The control unit configures memory to load the value in address 14 into register 0. We increment the instruction address register to 1, and the first cycle is complete. We begin the second cycle by fetching the instruction in memory location 1 and loading it in the instruction register. The control unit then decodes it. This time, the opcode 0001 is the code for load 1. Read an instruction from the memory location provided and place it in register 1. The address provided is 1111 or 15 in decimal. With the second instruction decoded, the control unit executes the instruction by configuring memory to load the value located in address 15 into register 1. The instruction address register is incremented to 2 and the second cycle is complete. We begin the third cycle by fetching the instruction in memory location 2 and loading it into the instruction register. The control unit then decodes it. This time the opcode is 1000, which is the code for add, to add the 2 registers provided and place the results in the second register. The 2-bit register IDs provided are 01 and 00. The control unit then executes the instruction by enabling register 1 and passing its value into the ALU. It then enables register 0 and passes its value into the ALU. Since the ALU can perform a number of different operations, the control unit configures it to perform the addition operation. The ALU returns the result, which in this case is 3 plus 14, which is equal to 17, or in binary, 000100001. Returns this value to the CPU, which then stores it in register 0. The cycle is completed by incrementing the instruction address register to 3. We begin the fourth and final cycle in our example by fetching the instruction in address 3 and loading it in the instruction register. The control unit then decodes it. This time, the opcode is 0100, the code for store 0, to store the value of register 0 in the memory location provided, which in this case is location 1101, or decimal address 13. The control unit then executes the instruction by passing the value in register 0 to memory and configuring it to write the data to memory location 13. We increment the instruction address register to 4, and our example is complete.